What if aging is not as unavoidable as we have always believed? Most people are taught that growing older is simply the result of time passing. The years go by, and the body gradually loses function. It is often accepted as a normal part of life. Yet another perspective suggests that aging may be shaped less by the calendar and more by biology, environmental influences, and the health decisions we make every day. From this viewpoint, aging is not driven solely by the passage of time. Instead, it is connected to intricate biological mechanisms that can be influenced and, in some respects, partially reversed. This idea is not science fiction. It comes from scientific investigations currently taking place in research facilities around the world. One particularly exciting area of study involves rebuilding muscle tissue. Traditionally, muscle growth is associated with long hours of training and physical exertion, especially later in life. However, evidence suggests that a single ingredient may help support muscle restoration in older adults without demanding intense exercise. The implications extend beyond physical strength alone. They may also affect health span, the years during which people remain energetic, capable, and free from many of the most serious effects linked to aging. To understand this possibility, it is important to first examine how muscle regeneration works. When people think about gaining muscle, they often imagine lifting weights, sprinting, or performing challenging workouts that stress muscle fibers and encourage them to grow back stronger. For many years, this has been considered the primary route to muscle development, particularly for older adults. However, muscle rebuilding can occur through additional mechanisms. As the body ages, muscle mass and strength naturally decline. This condition is known as sarcopenia. The process becomes more noticeable after the age of 30. By the 6th and 7th decades of life, the consequences can become significant. The impact goes far beyond appearance or physical performance. Reduced muscle mass can lead to mobility problems, an increased likelihood of falls, and a general reduction in quality of life. Even so, the body continues to possess the ability to regenerate muscle tissue throughout later life. Muscle repair is an ongoing biological process. Whenever muscle fibers are damaged or challenged, specialized cells called satellite cells become active. These cells function as the stem cells of muscle tissue. Normally, they remain inactive. When needed, they awaken and begin repairing and rebuilding muscle fibers. The challenge is determining how to reactivate this regenerative system in older individuals, whose recovery processes often slow with age. Research has uncovered a promising answer. Scientists have identified a nutrient-driven signaling process capable of enhancing muscle regeneration without relying primarily on strenuous physical activity. Certain nutrients, especially specific amino acids and related compounds, can send signals that encourage the body to accelerate muscle repair. In other words, rebuilding muscle may not always require marathons or heavy lifting. Sometimes the body simply needs the proper biological message. Among the most important contributors is leucine, an amino acid present in protein-rich foods. Studies have demonstrated that leucine can stimulate proteins involved in muscle production, making it a critical component of muscle rebuilding. The story extends beyond leucine alone. When paired with additional nutrients and bioactive compounds, leucine can help activate a broader network of cellular pathways. These pathways support muscle health by encouraging satellite cell activity and promoting protein synthesis. Researchers have also identified another ingredient capable of influencing these regeneration mechanisms. That ingredient is hibiscus extract. This is the same flower that has been utilized for centuries within traditional medicine practices. Studies indicate that hibiscus extract may activate biological pathways associated with muscle regeneration without requiring heavy exercise. Its effects are linked to a rich concentration of polyphenols, compounds believed to stimulate the mTOR pathway, an important regulator of muscle growth. Once introduced into the body, hibiscus may act as a signal that encourages muscle repair mechanisms to become more active, even among individuals who are unable to participate in conventional exercise programs. By supporting these regenerative pathways, hibiscus extract may help older adults rebuild muscle mass and strength. This could contribute to maintaining mobility, preserving independence, and lowering the risk of age-related conditions such as frailty and osteoporosis. In simple terms, the extract functions like a gentle signal that reminds the body to perform a task it already understands how to do: repair, rebuild, and regenerate muscle tissue. This raises an important possibility. If older adults could recover lost muscle through a straightforward natural intervention rather than exhausting workouts, the way society approaches aging, health span, and later life well-being could change dramatically. As scientific understanding of muscle growth and repair continues to advance, additional pathways that support resilience and vitality may emerge. Imagine that an invisible brake exists inside the body, constantly limiting muscle growth and preventing muscles from reaching their full potential. As people grow older, this braking mechanism becomes increasingly influential, making it progressively more difficult to recover muscle that has been lost over time. This biological brake is known as myostatin. Myostatin functions as a negative regulator of muscle development. Its role is to signal the body to slow or stop muscle growth, and it performs that task very effectively. Evidence for its power can be seen in individuals who possess mutations affecting the myostatin gene. These individuals have displayed unusually large amounts of muscle mass and strength despite not participating in intensive exercise programs. It is as though their bodies have significantly reduced or removed the brake, allowing muscle-building systems to operate with far fewer limitations. For most people, however, myostatin remains active, keeping muscle growth under control and preventing excessive accumulation of muscle tissue. This leads to an important question. What happens if the effects of myostatin are reduced? Could limiting this protein allow aging individuals to rebuild muscle in ways that challenge traditional expectations? Recent studies suggest that myostatin inhibition may provide an answer. Researchers have been investigating methods to block or lessen myostatin activity, and the findings have generated considerable interest. Lower myostatin activity appears capable of allowing the body to develop additional muscle, even during later stages of life. This potential breakthrough is not limited to athletes or bodybuilders. It may be particularly valuable for older adults who face the greatest risks from muscle loss and frailty. What makes the research even more intriguing is that influencing myostatin may not require gene editing technologies or costly medical procedures. Natural approaches appear capable of affecting this pathway as well. One of the most promising methods involves nutrient signaling. Earlier discussion focused on compounds that encourage muscle regeneration. Researchers have also examined whether some of these same compounds can influence myostatin levels. Among the ingredients receiving attention is hibiscus extract. The same extract associated with muscle repair may also affect myostatin activity. Investigations have reported that hibiscus, because of its rich concentration of polyphenols, not only supports regenerative processes, but may also influence the myostatin pathway. Hibiscus presents a dual effect against age-related muscle decline. It encourages the body to regenerate muscle, while also reducing molecular breaks that limit growth. But hibiscus is not the only natural compound able to influence myostatin. Other agents, such as epicatechins found in cocoa and green tea, and resveratrol present in red wine and grapes, have been shown to lower myostatin expression. Together, these compounds can help the body rebuild muscle more efficiently, without the need for daily intense workouts. Imagine approaching muscle regeneration in a more accessible, holistic way. Rather than relying solely on heavy exercise, natural compounds can assist the body in overcoming the obstacles of aging. This approach is particularly valuable for older adults who may not have the physical capacity for rigorous lifting, but still wish to regain muscle strength and function. If muscle building depends not only on lifting heavier weights, but on providing the body with proper regenerative signals, then our approach to aging itself may need reconsideration. What if influencing the biological systems that control muscle growth could be achieved simply through smarter dietary choices? The body may be one step away from unlocking its full muscle-building potential, not through extreme exertion, but by harnessing the natural power of myostatin inhibition. As molecular understanding progresses, more solutions will likely appear to help maintain strength, resilience, and independence across all ages. Another crucial element in muscle regeneration is nutrient signaling. The foods we consume do more than supply raw materials. They communicate with our cells, activating or deactivating pathways that shape how effectively muscles repair and grow. Among these nutrients, protein plays a central role, particularly amino acids like leucine. Leucine activates the mTOR pathway, a key regulator of muscle protein synthesis. Yet protein is not the only path to effective nutrient signaling. Hibiscus extract, the same flower known for deep red blooms and soothing teas, has demonstrated exceptional promise in triggering muscle repair pathways. Beyond its antioxidant effects and cardiovascular benefits, hibiscus can activate the mTOR pathway like leucine, without requiring high protein intake. It stimulates nutrient-sensing pathways that govern cellular growth and repair. Its polyphenols, specifically flavonoids such as quercetin and camperol, combat oxidative stress while supporting muscle rebuilding. Hibiscus extract has been shown to reduce myostatin effects, activate satellite cells, and enhance protein synthesis even without intense exercise, creating an environment for efficient muscle regeneration. This discovery suggests that a single, natural ingredient could dramatically impact muscle health, especially for older adults seeking alternatives to exhausting physical regimens. Hibiscus works in harmony with the body's biology to optimize muscle rebuilding without extreme effort. Other nutrients also contribute, including omega-3 fatty acids from fish and plant oils, vitamin D, and creatine, which help muscle function, strength, and recovery. Combining these nutrients may form a comprehensive, natural strategy for maintaining muscle. This approach allows aging individuals to rebuild strength and protect the body through mindful nutritional choices rather than grueling gym sessions. By focusing on how food signals to muscles, it becomes possible to enhance repair and growth. Nutrient signaling highlights the importance of selecting the right foods and supplements to actively influence the biological processes that sustain muscle, mobility, and independence. Aging at the cellular level also plays a critical role. Senescent cells, which have reached the end of their useful life but fail to die, accumulate in tissues throughout the body. These cells cease dividing, but remain active, producing chemicals that disrupt healthy neighbors and cause inflammation. This phenomenon is called the senescence-associated secretory phenotype, or SASP. Senescent cells contribute significantly to age-related muscle loss. Their accumulation slows regeneration, impairs satellite cell function, and limits new muscle growth, directly contributing to sarcopenia. Encouragingly, research shows that selectively removing senescent cells, a process known as senolysis, can restore tissue function. In animal models, clearing these dysfunctional cells improves muscle regeneration, boosts strength, and reverses several signs of aging. Compounds called senolytics target these cells, creating a more youthful environment for repair. By eliminating biological clutter, senolytics enhance the body's capacity to rebuild and heal. Quercetin, found in apples, onions, and tea, is one such compound that effectively targets senescent cells. When combined with dasatinib, a cancer medication used at very low doses, researchers have found that the pair can efficiently remove senescent cells from the body and improve muscle function in the process. The implications for older adults are striking. This approach is not simply about slowing muscle loss. It raises the possibility of reversing part of it. If safe and accessible methods for clearing senescent cells from muscle and other tissues become available, a new frontier in aging research could emerge, one in which strength and mobility thought to be permanently lost may be partially regained. That leads to another important question. What if intervention begins before advanced age? What if senolytic compounds are used earlier, even during midlife, to slow or reverse aspects of cellular aging before they significantly erode muscle mass, energy, and vitality? This proactive strategy remains in the early stages of research, but the potential is considerable. As investigation continues, these tools may prove useful not only for extending lifespan, but for improving health span, the years spent functioning well rather than merely surviving. For now, the discussion turns to practical foundations. Balanced nutrition, lowering chronic inflammation, and the possible use of natural compounds such as quercetin are presented as ways to support healthier aging and reduce conditions that may favor the buildup of senescent cells. Another major piece of the puzzle is mitochondrial health. Mitochondria are often called the powerhouses of the cell because they generate ATP, the energy currency required for life. But their role extends beyond energy production. They are central to muscle function, strength, endurance, and recovery. With age, mitochondrial performance declines. This deterioration is frequently cited as a major contributor to weakness, fatigue, and the progressive loss of muscle mass seen in older adults. Mitochondria are not static structures. They continuously undergo fission, splitting apart, and fusion, joining together, in response to the body's changing energy demands. This flexibility is known as mitochondrial plasticity. As aging progresses, plasticity decreases. Mitochondria become less efficient, energy production falls, and a cascade of problems can follow, including poor muscle regeneration, greater oxidative stress, and increased inflammation. The encouraging news is that mitochondria are not passive victims of aging. Their function can be influenced through lifestyle, diet, and targeted interventions. Several nutrients are highlighted for their role in supporting mitochondrial performance. Coenzyme Q10, commonly abbreviated CoQ10, is described as an antioxidant that helps maintain energy production within mitochondria. Supplementation studies have reported increases in energy and improvements in muscle function, particularly in older adults. Another key molecule is NAD+, which is essential for cellular energy production and mitochondrial activity. NAD+ levels naturally decline with age. Research suggests that precursors such as nicotinamide riboside, NR, can raise NAD+ levels and improve mitochondrial health, with promising effects on muscle function, endurance, and recovery in older individuals. Hibiscus extract also reappears in this context. Its polyphenols, especially quercetin and kemperol, are described as reducing inflammation and oxidative stress while supporting mitochondrial biogenesis, the creation of new, healthy mitochondria. In practical terms, the argument is that hibiscus may improve energy production and muscle performance from the inside out. The analogy used is that of an aging engine. As the engine wears down, efficiency drops. Supplying the right fuel, in this case specific nutrients, may help restore performance. Healthier mitochondria mean muscles receive more usable energy, recover faster, and function better over time. The broader lesson is that aging is not portrayed solely as unavoidable decline. It is also a process of adaptation that may respond to interventions. Prioritizing mitochondrial support through nutrition, physical activity, stress management, and a nutrient-dense diet is presented as a strategy for preserving strength, endurance, and vitality later in life. The discussion then widens to longevity research. For decades, aging was viewed as an irreversible process that could perhaps be slowed, but not meaningfully altered. Advances in genetics, cellular biology, and regenerative medicine have begun to challenge that assumption. Aging is increasingly described as a dynamic process that can be influenced, reprogrammed, and in some respects partially reversed. One of the most closely watched developments is biological reprogramming, the idea that altering specific cellular pathways may restore youthful functions and slow or reverse key hallmarks of aging. Proposed targets include tissue regeneration, DNA repair, and maintenance of cellular integrity. Epigenetics is presented as a central example. Genes provide the blueprint, but changes in gene expression can strongly affect how aging unfolds. Research has shown that certain genes can be shifted toward a more youthful expression pattern, improving cellular function. Nutrient signaling is woven into this framework. Nutrients do not merely provide calories or building blocks. They send biochemical messages that influence pathways involved in repair, regeneration, and rejuvenation. Senolytics remain one of the most promising research areas. By removing senescent cells, scientists aim to restore tissue function and improve the body's regenerative capacity. Animal studies have reported extensions of lifespan, improvements in health span, and reversals of frailty, muscle loss, and metabolic decline after senescent cell clearance. The field is still evolving, but significant advances are anticipated in the coming years, with the expectation that senolytic therapies may eventually become publicly available. The concluding message is that aging is framed not as a fixed destiny, but as a process that can be shaped. Choices related to nutrition, inflammation, mitochondrial support, and emerging longevity interventions are presented as tools that may influence how strength, function, and vitality change over time. Take care of your body, support your cellular health, and make deliberate choices that favor resilience, mobility, and long-term well-being. Researchers have reported that when quercetin is paired with dititin, a cancer drug administered at very low doses, the combination can remove senescent cells from the body and improve muscle function. The implication is significant for older adults. The goal would not be merely to slow muscle loss, but potentially to restore strength and mobility that were assumed to be permanently gone. This raises another question. What if intervention began earlier rather than waiting until advanced age? The concept of using senolytic compounds during midlife to slow or reverse cellular aging before it causes major losses in muscle mass, energy, and vitality remains in the early stages of research, but the potential is substantial. As investigations continue, these approaches may eventually provide tools that extend not only lifespan, but health span, the years spent functioning well, rather than simply remaining alive. At present, practical steps aimed at reducing the accumulation of senescent cells focus on maintaining a balanced diet, lowering chronic inflammation, and considering natural compounds such as quercetin as part of an overall healthy lifestyle strategy. Mitochondrial health represents another central theme in aging and muscle function. Mitochondria generate ATP, the energy currency that powers cellular activity. They also help maintain muscle strength, endurance, and recovery. With age, mitochondrial function declines, contributing to weakness, fatigue, and loss of muscle mass. Mitochondria are not static structures. They continually undergo fission, splitting apart, and fusion, joining together, in response to the body's energy needs. This adaptability is known as mitochondrial plasticity. Aging reduces that plasticity, making energy production less efficient and increasing oxidative stress, inflammation, and impaired muscle regeneration. The encouraging finding is that mitochondrial health is modifiable. Diet, lifestyle, and targeted nutrients can influence how well mitochondria function. One example is CoQ10, an antioxidant that supports mitochondrial energy production. Studies indicate that CoQ10 supplementation can improve energy levels and muscle function, particularly in older adults. Another key molecule is NAD+, which regulates cellular energy production and is essential for mitochondrial activity. NAD+ levels naturally decline with age. Research suggests that NAD+ precursors such as nicotinamide riboside, NR, can restore NAD+ levels and improve mitochondrial health. Early findings show promise for better muscle function, endurance, and recovery in older individuals. Hibiscus extract also appears in this discussion. The polyphenols quercetin and kemperol have been linked to reduced inflammation and oxidative stress, while also supporting mitochondrial biogenesis, the formation of new mitochondria. By promoting healthier mitochondria, hibiscus may enhance energy production and muscle performance from within the cell. A useful analogy is an aging engine. Over time, efficiency falls. Supplying the right nutrients is comparable to providing the engine with higher quality fuel and maintenance, allowing it to regain performance. Healthier mitochondria mean more energy for muscles, faster recovery, and better function during exercise and everyday activities. Protecting mitochondria therefore involves more than supplements alone. Regular physical activity, stress management, and a nutrient-dense diet remain important components of the strategy. Longevity research brings these ideas together. Aging was long viewed as inevitable and irreversible. Advances in genetics, cellular biology, and regenerative medicine now suggest that aging is a dynamic process that can be influenced and, to some extent, partially reversed. One of the most promising concepts is biological reprogramming, influencing cellular pathways to restore more youthful function. This includes muscle regeneration, DNA repair, and maintenance of cellular integrity. The aim is not only to add years to life, but to add healthy function to those years. Epigenetics illustrates this principle. Genes provide a foundation, but changes in gene expression can significantly affect aging. Research indicates that some age-related gene expression patterns may be shifted toward a more youthful state. Nutrient signaling is relevant here because nutrients act not only as fuel, but also as signals that activate pathways for repair, regeneration, and rejuvenation. Senolytics remain a major area of interest. By targeting and removing senescent cells, researchers hope to restore tissue function and improve regeneration. Animal studies have shown that clearing these cells can extend lifespan, improve health span, and reverse conditions such as frailty, muscle loss, and metabolic decline. The field is active, and many investigators expect important developments over the next few years as senolytic therapies move closer to broader public availability. The overarching message is that aging may be shaped by biological processes that can be influenced. Muscle regeneration, mitochondrial function, senescent cell clearance, nutrient signaling, and epigenetic regulation are all being studied as interconnected pieces of a larger puzzle. The emerging goal is not merely longer life, but longer periods of strength, mobility, resilience, and independence. If these insights were useful, consider sharing this information with someone interested in healthy aging and longevity, and continue exploring evidence-based approaches that support strength, energy, and vitality across the lifespan. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.